So with all of my lumber milled up, I calculated a rough space I think I'd need for the actuator, and then on either side of that is where I'm going to have my two posts that will connect the base to the top, and those posts will also serve as the frame for holding the cradle that rides up and down in the base. So then I offset another inch and I put an angle to the bottom. These are all just kind of measurements I pulled as I was drawing them. It's a very simple design. It's almost very shaker style, like with some simple lines, not a lot of detailing, but also not square ends. So the pile I'm pointing at are going to be the vertical parts, which I haven't cut down to final size yet. I just trim the edges, and you could once again see how nice that grain is. And once I figure out the height of where the actuator will sit is when I'll cut these down to final size. So I have these rough laid out on top. It's basically what they're going to look like, and then I could go through and cut my tenons. So these are going to be pretty big mortises, fairly large tenons. I am going to give myself a little bit of space on the side, a slight 1/8 inch of a shoulder, so that I don't have to worry about seeing any gaps when these are in place. But essentially I'm just cutting out a fairly large tenon. You can do double tenons on these if you want, but I decided to go with full tenons on the bottom. So mortises are pretty easy to cut in my shop as long as the lumber will fit in this machine. I basically am just going to be doing a line of 3/8 inch mortises on the top and bottom, and then I'll drill out the excess with a spade bit. You could drill all of these on the mortising machine, but it will take quite a while. So you can see I have the fence lined up so that it will cut the same distance from the front and the back, so I can go through and do all of this at once without moving the fence, and then I'll know they're also perfectly symmetrical. So once you have that first mortise hole drilled, it's pretty easy work because the chips have somewhere to go at this point. And you can see I'm just doing a line on the front side of both of these. Once that's done, I can flip it and do it the line on the back. So I'll get a nice reference point in the front and the back, and then like I said, I'll drill out the rest. It will be much faster doing it that way. So since this was that yellow pine, and I've already mentioned it was quite sappy, it really gummed up most of my tools as I was doing this, which I'm not really used to. Modern pines usually don't have as much sap in them as this, but it does machine pretty nicely aside from that. So once I had that first one cut, remember there are 4 of these in total, so I'm going to have to do this on 3 other ones. I just transfer all of my marks to the other pieces, and then I'll go through and do the exact same thing on the other 3. So on this process with all these videos, I usually don't show doing everything multiple times. I'll show it on the first one, and then obviously I'm doing it for all of them. At this point, I have an 1.5 inch spade bit I'm going to drill out the rest of these with. I have a marked line as the offset so that I don't go past that marker, and then I can just have this clamped in my drill press with the depth set on the drill press, and you can see this lines up perfectly, and I could just drill 2 plugs out. There will be a little bit of material to remove after those plugs are drilled, but like I said, this is much faster than doing this all on the mortising machine. Before I had the mortising machine, this was how I used to do all of my mortises anyway, so it's a pretty good process if you don't have a mortising machine. So that's basically what that's going to look like, and I'm just going to go through. I could move it, tighten it up. These spade bits will grab on you, so it's always smart to clamp your workpiece down, especially on bigger size bits with this. If it catches the wood and it's not clamped down, it could really cause some problems. And that is basically what that's going to look like. So you can see there's a little bit of material on both ends I'll have to remove, but in general it takes out 95% of that wood. And like I said, this wood machines very nicely, so chiseling out the rest of it was not difficult work. And then like I said, there's 4 of these, so I did this to all of the pieces. And then I could take them to the top of the table saw and chisel out those flanges on the side. The mortising machine, if you go over everything in 2 passes, it leaves a pretty clean mortise. Instead of taking the time to do that, I usually opt to just clean up the bottom of those mortises with a chisel as well. But you can see that's pretty quick work, taking down those 2 flanges, and then I'll have those nice open mortises, and I can measure and cut the tenons at this point. So there's that first hole cleaned up, and then working on the second one. And I was pretty happy with how these turned out. So this is just rough math, measuring for the actuator, because there are 2 mounting brackets I had to account for, and I also had to account for the depth of it going onto the base. So that's basically what this rough math is. Like I said, I will eventually have plans for these, but basically I came to the conclusion that I needed to calculate for the depth of the tenons, calculate for the actuator, and that number came to 26 inches. So I could go through and final cut my verticals all down to 26 inches. This table is at the top end of the standard recommendation for desks. I have this at 30 inches is the final height, and that is because the person I'm making this for is rather tall, so that is a consideration to be had when you're making any sort of furniture. There's usually a window of sizes you can go with, but especially stuff like desks and tables, depending on who's going to be using it, you either want to stay towards the bottom end of that window or the top end, and in that circumstance I wanted towards the top end. So once I had those 26 inches cut down to size, I did a test cut for all of these tenons. So you can see the first thing I'm doing is test cutting the width of this, calculated with that 1/8 inch shoulder. So the 2 sides of this, I'm removing a very small amount of material. Now the way I like to cut stuff like this is on the radial arm saw, because it leaves the table saw open for other things I'm working on in the shop. It's not the fastest way to cut curves and joints, but it's very easy to set up with a stop and get consistent results, which is why I usually choose to do it. So once those curves are all cut, you can see I can remove the leftover flanges, and then that is going to be the first series of cuts to get these to fit into that joint. Once that's done, I can measure the other measurement, and you'll see I can lower the blade to match up with that line. And once again, before I go and cut my final pieces, I'm doing all test cuts on this piece of scrap here, make sure everything fits, and then I could send all 4 of my verticals through, and obviously I'm cutting both ends of these. So there's the test piece, and once that fits into place nicely, this is the fit I'm looking for, snug but not too snug, I'm going to go through and cut all of my other pieces. The other plus side to this lumber milling up so nicely is that if this stuff isn't square on the radial arm saw, a lot of times you'll have to do specialized fitting of these joints, because it will leave a lot of undulations on the cut surface. So like I keep saying, it was nice how flat I got these. There wasn't a lot of cleanup for these tenons in order to get them to fit into place. So you can see I'm doing one side and then the other side as well, making a series of curves, and then I could just go through. Since these flanges are a little bit bigger, I start with a hammer to remove most of the material, and then once again I could clean up the rest with a chisel. And like I keep saying, this lumber machined really well. It was really nice lumber to work with. And then I could flip it over, do the exact same thing, and then once I had all these done, I could test piece these edges together. Before I went through and test fit those pieces, I trimmed off the bottom of these. There's multiple ways to do this, but the depth cut on this My chop saw is much deeper than the radial arm saw, so you can see I just set up an angled stop, and I could slide this up to the fence and then cut the edges off of these. This also leaves a really clean cut. I didn't have a lot of sanding to do on this material, which was nice. It machined so nicely, everything was quite smooth. So those are going to be my angled edges. You can see there's some residual termite damage left over, and I like the look of that in reclaimed lumber, but if that's not your thing, that's also something you consider working with this older material, because most of it will have some sort of bug damage. And then once again, there's most likely a much faster way to do this, but I usually do this on the table saw with my cross-cut sled, and that is I'm removing about 1/4 of an inch from the bottom, 1/4 of an inch high material for the majority of the bottom of this. That is because I want the weight of this table to sit on the two ends, not the entire bottom of the piece. If you have it sitting on the entire bottom of the piece, the chances of wherever you're putting this, the floor being perfectly level is pretty small, which means it's most likely going to have a higher tendency to rock back and forth. If you remove some of the surface area from the bottom of these bases in all circumstances when building, then you're left with only 2 smaller pressure points, and it's much easier to level it if the floor is severely unsquare. So like I said, there's probably a faster way to do it. I usually do it on the table saw. Once again, a bunch of kerfs, remove the material, and you'll never really see this. You don't have to get crazy with removing the bottom of it. But what I like to do is once I have the bulk of the material off, I could slowly slide this back and forth on the table saw, and the blade will clean up the rest of this for me. And that is what that looks like. Pretty simple process that could save you a lot of headache once you go to put this in place. It's just a very small amount of material removed from that bottom. And then once that was done, I could test fit my tenons in place. There's usually a little bit of cleanup to do on these. I don't think I filmed it for this one, but they usually don't fit. I always make everything a hair oversized and then go through and use a rasp to remove some material and clean up the mortises a little bit more, because I want them to be a fairly tight fit. But that was the bottom, and then the top I could hammer into place. Obviously there's 2 of these, and up until this point this is a very simplistic table build. The next couple of videos is when we're going to start talking about setting up the actuators. You'll kind of get a rough idea how they fit in place there, and working on more intricate joinery in order to get this to work.